Hey class, welcome to our review for the Chapter 5 test on inequalities. Your test is coming up next week, so this video will review all of the important topics that will be featured on that test. This is your last test of the quarter, so please make sure to use this video to prepare as much as possible so that you come in confident with all of the skills we're about to go over. Now, before we get into solving inequalities, I just want to remind you of one of the major keys we learned in this chapter, and that was that if we multiply or divide by a negative, that means we have to flip our sign. And when I say sign, I mean our inequality sign, flip our symbol. Okay? So let's keep that in mind while we practice our first couple of questions. These are all multi-step inequalities that need to be solved for the given variable. And then they want us to graph our solution on a number line. Always read your directions so you know if they're asking you to do that. Now for the first one, we have parentheses, so we need to first distribute to get rid of those parentheses. So this becomes 6 minus 3b is less than 10 minus 3b plus 18. Now we have like terms, so the next step is to combine those. Negative 3b plus 28. Now I already have my b on the left side. I want to keep it there. I like when my variable's on the left. So I'm going to move the 6 to the other side. So that's negative 3b is less than negative 3b plus 22. Now at this point, we have to combine the b's. So I'm going to add these 3 to both sides, and it cancels out over here. Now on this side, it's still negative 3b plus 3b. So that leaves us with 0. There are no b's left, but I don't want to just leave it blank because that will throw me off. So I leave the 0 there. So 0 is less than 22. Now when we get to this point, if we've eliminated all of our variables, then we have to look at the final statement to decide, is that true or false? If it's true, our answer is all real numbers. If it's false, then there is no solution. So thankfully, this one is true. So our answer is all real numbers. And that's how you would leave it. Now for the next one, we have 4m minus 17 is less than 6m plus 25. So the first thing we're going to do is add 17 to both sides. So we get 4m is less than 6m plus 42. Then we're going to subtract 6m from both sides. And we get negative 2m is less than 42. And then we want m alone, so we're going to divide by negative 2. Now, my spidey senses are tingling. I just divided by a negative. I should remember that means something. That means we have to flip our sign. So m is greater than negative 21. So there's our solution to this inequality. But they also asked us to graph it on a number line. So to do that, I'm going to put negative 21 on my number line. It's an open symbol, so I want an open circle. And then my inequality states that m is greater than negative 21. So my arrow is going to go to the right. Now, the next two are compound inequalities. We know that because they have more than one inequality symbol in the expression. So to solve these, we first split it up into two separate inequalities. So that would start with 6 is less than or equal to r plus 7. And then r plus 7 is less than 10. Now we solve for r on both sides. So minus 7 So we get -1 is less than or equal to r, and then -7 on this side, r is less than 3. Now, if it's a compound inequality, we want to write it together. So we are going to combine this into -1 is less than or equal to r is less than 3. Now, we have to still graph it on a number line. So I know I want to include -1 and +3 on my number line. And I'm going to start by just looking at this first part. -1 is less than or equal to r. So I need a closed circle above -1, and then my inequality is telling me that r is greater than or equal to -1. So my line goes to the right. Remember, r is on the right side. So we're not going to use the symbol to tell us which way to go, because that only works if the variable is first. So because it's a compound inequality, I'm just going to draw like a little line, but I'm not going to connect it yet. Now I do the second part, which is r is less than 3. Now this is an open symbol, so we use an open circle, and then we want to point towards all the numbers less than 3, which is to the left. So then those lines connect, and our intersection here represents our solution. Now let's do one more compound inequality. This one is 7 is less than z plus 2, which is less than or equal to 11. So I'm going to split this up. 7 is less than z plus 2, and z plus 2 is less than or equal to 11. Now let's get z alone. So 5 is less than z, and then z alone on this side, z is less than or equal to 9. Now, we want to combine this into one statement. So 5 is less than z, which is less than or equal to 9. And our last step is to put it on a number line. So I want +5 and +9 on my number line. I'm going to start with z is greater than 5. It's an open symbol, so I'm going to have an open circle, and we want to point towards all the numbers that are greater than 5. The second half is z is less than or equal to 9, so that's a closed circle above 9, and then our arrows going to the left. So those are our inequalities, the solutions, and their solutions graphed on number line. Now let's look at some compound inequalities that are a little trickier. So these are asking us to find the solution and then again graph it on a number line. This first one is an and inequality. So I'm going to solve them separately and then graph them together on the line. So this is -4a plus 13 is greater than or equal to 29. We are going to subtract 13 from both sides so that we get -4a is greater than or equal to 16. And then we divide by -4. But we have to remember, we're dividing by a negative, so we flip our symbol. So the first one is a is less than or equal to -4. And then we'll do the other side. 10 is less than 6a minus 14. So we add 14 to both sides. 24 is less than 6a. We divide by +6, so we don't have to flip any symbols, and we get 4 is less than a. Now, this is saying that a needs to be, let's see, we have -4 and +4. If we put it on our number line, a needs to be less than or equal to -4. So that's a closed circle, and our arrow is going to -4, or to the left of -4. And then our next symbol is 4 is less than A. So that's an open circle with our arrow facing to the right. Now, if this had been an or inequality, great. This would be our answer. Oops, sorry guys, there you go. This would be our answer. This would be awesome. But it's an and inequality. An and inequality needs an intersection of the lines to show us what the answer solutions could be. So here, because our two inequalities do not intersect, they are going opposite directions, this is no solution. Again, if it had been an or inequality, then yeah, this would be fine. But and, we can't have a number that is less than -4 and also greater than 4. There is no such number that exists. So that's why it's no solution. Let's do the other one. So this one, we have 422 is greater than or equal to 4m minus 2. And then we have 5 minus 3m is less than or equal to -13. Now that we have both of our inequalities written down, let's solve for m. So on this side, we're going to add 2. That gives us 24 is greater than or equal to 4m. And then we're going to divide by 4 on both sides. So that gives us 6 is greater than or equal to m. Now on this side, we're going to do the same thing. We're going to isolate our variables. So we'll start by subtracting 5. That gives us -3m is less than or equal to -18. We'll divide by -3. Now we divided by a negative, so we need to flip our symbol. So m is greater than or equal to 6. Now, this is an or statement. So it's telling us that m could be any number that is less than or equal to 6. So we're going to do a closed circle, and our arrow goes to the left to represent the numbers less than or equal to 6. And then m is also greater than or equal to 6. So our arrow is going to go to the right. Notice, it's a closed circle, and our arrows are going indefinitely in both directions. That means everything on this number line would work as a solution. So our answer is all real numbers. Okay? So those are our basic inequalities and compound inequalities. Now let's talk about graphing our inequalities. When graphing inequalities, we want to remember the 3 steps we talked about. First, we get our inequality into slope-intercept form. Then, we decide if our line is going to be solid or dashed, and we graph it on the coordinate plane. And lastly, we pick a test point, we test it, and then we shade the solution side. So let's try that with our first example here. 5x minus 2y is less than 10. We want y alone, so I'm going to start by subtracting 5x. That's going to leave -2y is less than -5x plus 10. Now, we're not done because there's still a coefficient in front of the y. So we're going to divide by -2, and we get y is greater than +5 halves x minus 5. Now that's our inequality in slope-intercept form. Now we can graph it. So on our coordinate plane, our y-intercept is -5. So we're going to go down to -1, 2, 3, 4, 5. And that's our y-intercept. That's our starting point. Our slope is +5/2. So we're going to go up 1, 2, 3, 4, 5 over 2. Up 1, 2, 3, 4, 5 over 2. Now, before we draw our line, we have to decide, is it going to be solid or dashed? Now this one, because it's an open symbol, it's going to be a dashed line. So we're going to connect our points with a dashed line. Make it as straight as possible. Use your straight edge on a test. And then after we draw our dashed line, we need to start figuring out what our test point is going to be and testing it. So I'm going to label my sides A and B just so I don't get them mixed up. And I'm going to use 0, 0 as my test point because that makes it nice and simple. Remember, the test point just can't be anything on the line. So now we take that point and we plug it into our inequality. 0 is greater than 5 halves times 0 minus 5. So 0 is greater than -5. This is a true statement, so that means the side that the test point is on, side A, is true. So that's the side that will get colored in. All right, now the next one, we have y minus 2x is greater than or equal to -4. We want y alone, so the 2x, or the -2x I should say, needs to move to the other side. So I'm going to use my inverse operations to do that. So y is greater than or equal to 2x minus 4. Now we have our inequality. To graph it, we're going to start at -1, 2, 3, 4. -4 as our y-intercept, and our slope is +2. So that's up 2 over 1, up 2 over 1, up 2 over 1. Now, I look and see, is it going to be a solid or a dashed line? This time it's a closed symbol, so this will be a solid line. So I'm just going to connect it with the solid line as straight as possible. This one's a little messy. And then I'm going to label my sides and pick my test point. So my test point is 0, 0, so 0 is greater than or equal to 2 times 0 minus 4. So 0 is greater than or equal to -4. That is a true statement as well. So side A is our solution set for this inequality. All right, so that's a quick review of graphing on our coordinate plane using inequalities. And lastly, we're going to go over how to translate word problems into inequalities and then solve them. So our directions tell us to define a variable, write an inequality, and then find our solution for the problems below. When we are translating word problems into inequalities, I highly encourage you to take it one word at a time and make little notes or mark up your question as you read through it. So for this one, it says 4 times a number, so 4 times a number, less 6. Let's talk about this for a second. If I have 6 less than 2, I would write that, I would write that as 2 minus 6. When it's less than, it flips the order. But if I just say 12 less 5, notice I didn't use the word then. So this is just saying 12 less 5, meaning minus 5. So we would keep it in that order. So here it says less 6, not less than. So that means we are just subtracting 6 from 4x. Now the inequality word is greater than. So we're going to use a greater than symbol, and greater than what? -2. So now we are going to rewrite this as our final inequality, which is 4x minus 6 is greater than -2. Now we have our inequality. We want to solve for x. So we'll add 6 to both sides. We get 4x is greater than 4. Divide by +4, and we get x is greater than 1. So our solution is x is any number greater than 1. All right, next up we have a fraction. Don't be scared. 3/4. All right, so that's 3/4 of, the word of means multiply, a number, that's x, decreased by, that's subtraction, 9, is at least, so if something is at least, that means it needs to be greater than or equal to that amount. So at least 42 means it needs to be greater than or equal to 42. Now we'll just put this all together. 3/4x minus 9 is greater than or equal to 42. So we'll continue by adding 9 to both sides. That gives us 3/4 x is greater than or equal 42 plus 9 is 51. Now, to get x alone, we have to multiply by our reciprocal. That leaves x by itself. 51 times 4 is 204 over 3, and that simplifies to x is greater than or equal to 68. 204 divided by 3 is 68. We didn't divide by any negatives, so it stays positive. All right, now let's finish up with Jack. Jack has no more than. So if something is no more than $5, that means it needs to be less than or equal to that amount. So in this case, Jack is shopping. Normally when we're shopping, we have a certain amount we can spend, and we can't just make money out of thin air, unfortunately. So we literally cannot spend any more than that. So the amount needs to be less than or equal to how much we have to spend. So whatever Jack buys needs to be less than or equal to the $24 he brought to spend on DVDs. Now each DVD is $4. So if each DVD is $4, that's 4 times the number of DVDs that he buys. Now, once he buy, we need to figure out how many DVDs can he buy at the most before he can't afford it anymore. So to do that, we're going to divide by the $4 for each DVD. And that gives us x is less than or equal to 6. So he can rent 6 DVDs maximum. He can't afford to buy any more than 6. All right, now, before we wrap up, I just want to go over, there are a couple things that will be on the test that are from previous chapters. These are also included in your study guide. So please make sure you are reviewing and practicing these skills from our last couple chapters. So you need to know and be comfortable and confident with finding the slope of a line, graphing with slope-intercept form, and finding the equation of a line if you're given 2 points. So please review these on your own in addition to what we just went over. And the last thing we're going to talk about is a reward for the effort you put into watching this video and taking the time to study. On the test, there will be a bonus question. There will actually be 2 bonus questions. One is a math problem and the other is a math fact. I am going to give you that fact right now, and if you can remember it, you can earn your bonus points. So the question is, in which Shakespearean drama is the word mathematics, in which Shakespearean drama is the word mathematics included. So Shakespeare has written a ton of material. One, and only one, unfortunately, of his drama plays has the word mathematics in it. That play is called The Taming of the Shrew. This is the only Shakespearean drama that has the word mathematics in it. All right, guys. So with that, our review is over. I encourage you to keep practicing on your own, and I look forward to seeing all your hard work pay off next week. Thanks a lot. Have a great afternoon, guys.